question. So in this question it's been asked that a compound gave the following data. Okay, so a compound is giving a data. The data is the carbon is 57.82%, oxygen is 38.5%, and the rest remaining percentage is hydrogen. So out of 100%, the 57.82% is about carbon, the oxygen is 38.58%, and the rest percentage is the hydrogen. Okay, also the one important data is given that its vapor density is 83. And what they are asking us to do, they are asking us to calculate the empirical formula and the molecular formula. Okay, and the atomic weights of carbon, oxygen and hydrogen is given, which are 12, 16 and 1 respectively. Okay, so this type of questions are very easy to solve. Okay, so let's see how can we tackle such questions. Okay, so in order to solve this type of question, first we have to make one small table. Okay, and the table is nothing but, first we have to make a column. How many? 1, 2, 3, 4 and 5. Okay, so let's see what is gonna be inside it. The first is gonna be the element. Okay, second is gonna be the percentage composition. Third is gonna be atomic weight. Okay, fourth is gonna be relative number of atoms. Okay, relative number of atoms, and the last is gonna be the simple ratio. Okay, how and what data is gonna be inside this tables, that we'll see now. Okay, so let's make the table properly. There we go. Yeah, perfect. Okay, so the thing is, first we have to write the elements. So how many elements over here we have? So we have carbon, we have oxygen and we have hydrogen. Okay, so we're gonna write down carbon, oxygen and hydrogen. Okay, what is the percentage composition of carbon? The percentage composition of carbon is given 57.82. So we're gonna write down 57.82. Okay, what is the percentage composition of oxygen? So it's given 38.58. Okay, so we're gonna write down 38.58. Okay, and what about the hydrogen? So in the case of hydrogen, they are saying the rest percentage, whatever left, so 100% minus the carbon plus oxygen is nothing but the percentage remaining for the hydrogen. So let's calculate what is the percentage remaining for the hydrogen. Okay, so when you subtract 100 minus 57.82 plus 38.58, you get the answer is equals to 3.60. Okay, so what is the percentage composition of hydrogen? Sir, it is 3.60. Correct? Okay, now second part is the atomic weight. Third part is the atomic weight. So atomic weight is given 12, 16 and 1. So they write down carbon is 12, oxygen is 16, hydrogen is 1. Perfect. Okay, now the relative number of atoms. So it's very simple. What to do over here? You have to divide the percentage composition by the atomic weight. Okay, percentage composition by atomic weight. So in the first case, what it would be? It would be 57.82 divided by 12. 57.82 divided by 12. Okay, what would be in the case of oxygen? In the case of oxygen, it would be 38.58 divided by 16. Okay, the first one 57.82 by 12, 38.58 by 16, and the last would be 3.60 divided by 1. 3.60 divided by 1. Okay, when you calculate this, you get, for the first you get the 4.81, second one you get the 2.41, and the third one you get the 3.60. What you get? 3.60. Okay, now it's very simple. Out of 1, 2 and 3, you have to select the smallest value. Okay, so 4.81, 2.41 and 3.60, which value is the smallest? So it's very simple. So 2.41 is the smallest, so you have to divide this and this, all the values, by 2.41. So it's gonna be 4.81 divided by 2.41 2.41 divided by 2.41 and 3.60 divided by 2.41. Okay, so you have to divide all the ratios by smallest number, okay, which is 2.41 over here. So when you divide 4.81 by 2.41, you get the answer is equals to 2. When you divide 2.41 by 2.41, you get the answer 1. Okay, and when you divide by 3.60 by 2, you at least get, you approximately get the answer 1.5. So 1.5 can be written as 3 by 2. Okay, can be written by 3 by 2. Okay, perfect. So this is the important step. Okay, till now what have we done? Let's revise. So basically we were solving this question. So in that the compounds data was given that the carbon percentage composition of carbon was 57.82, oxygen was 38.58, and it was said the rest is the hydrogen. Okay, vapor density was given 83, which we haven't used till now, and they were asking us to calculate the empirical and molecular formula. So as I said, whenever it comes to calculate the empirical and molecular formula, how do we proceed with that? We have to make one table. So table is following like element, percentage composition, atomic weight, relative number of atoms, and simple ratio. Okay, so what is gonna be in all these columns? So in the element, we have to write down all the elements present in the compound, which is carbon, oxygen, and hydrogen over here. Then in the second part, we have to write down the percentage composition of that element. Okay, and in the third one, we have to write down the atomic weights of these elements. Okay, then we have to divide the composition by the atomic weight. We have to divide the composition by the atomic weight. Okay, and when you do the when you divide the composition by atomic weight, you get the one answer. Okay, out of those all values, you have to select the one with the smallest digit. Okay, smallest one, which is 2.41 over here. And then after that 2.41, you have to divide all the numbers by 2.41. Okay, or the smallest value whatever you get. Okay, and then after you get this simple ratio, and after you get this simple ratio. Okay, now let's proceed further. So basically the ratio is carbon is to oxygen is to hydrogen is equals to 2 is to 1 is to 3 by 2. Now, as we have seen earlier also in the part of Gay-Lussac's law, that any atom cannot be 3 by 2. Like how it could be 3 by 2? 1 plus half. No, it cannot be. Half atom is what? Half oxygen. It's not possible. Half hydrogen. What is half hydrogen? There is nothing such called half. So there can never be fractions in the ratios. Okay, then there cannot be the ratios in the there cannot be the fractions in the ratio. Okay, so how can we remove this ratio fraction 3 by 2? So sir, if we can do one thing, we can divide the everyone by 2. So if we multiply 2 by 2, you get the 4. You get multiply 1 by 2, 1, so when you get 2, and when you multiply 3 by 2 by 2, so this 2 and this 2 gets cancel, and you end up with the new ratio, which is 4 is to 2 is to 3. Okay, now there is no fraction, so yes sir, we can accept this. So this we did this in order to get this. Okay, so new ratio is carbon is to oxygen is to hydrogen is equal to 4 is to 2 is to 3. Okay, so from this we get our first thing, which is called empirical formula. What do we get? We get the empirical we get the empirical formula. Okay, and how can we write the empirical formula? We can write C4. So C subscript 4, O subscript 2, and H subscript 3. Okay, it can also be written as C4H3O2. Okay, C4H3O2, both are correct, there is no issue with that. Okay, okay, now we have to calculate the one more thing, which is empirical formula weight. Okay, what do we have to calculate? We have to calculate empirical formula weight. Okay, so basically what is this? This is as same as the molecular formula weight. Okay, molecular weight. What is molecular weight? Whatever the number of atoms are present, we multiply that with their atomic weight, and we add all those number and we get the molecular weight. Similarly over here we have to do. Okay, So now how many carbon atoms are there? So 4. So 4 into 12. Atomic weight of carbon is 12. Okay, plus let me write down like this. So 4 into C, 2 into oxygen plus 3 into hydrogen. Correct? Okay. What is the atomic weight of the carbon? Sir, 12. So 4, 12. 4 into 12. What is the atomic weight of oxygen? Sir, 16. So 2 into 16. What is the atomic weight of hydrogen? 1. Okay. So when you multiply 12 by 4, you get 48. When you multiply 16 by 2, you get the answer 32, and the answer, so 3 into 1 is 3. So when you add all this number, you get the answer is equals to 83. You get the answer is equals to 83. So this is nothing but our empirical formula weight. Okay. So empirical formula weight is nothing but 83. Okay. Now next part. Next part is to calculate the molecular weight. Okay. Next part is to get the molecular weight. But sir, how can we calculate the molecular weight? We don't know the molecular formula. But dear, you have been given the vapor density. Now if you remember the part of the vapor density when you used to solve, we used to solve by molecular weight is equals to 2 into vapor density. We have vapor density. If we multiply it by 2, we get the molecular weight. So what is the vapor density? Sir, 83. So can we calculate molecular weight? Yes sir. Molecular weight is 2 into vapor density, which will be equal to 2 into 83, which is nothing but the 166. Okay, which is nothing but the 166. Now we have to calculate what is the formula of molecular formula. That's what we got the empirical formula. One part is done, okay, which is empirical formula, which was asked in the question, that calculate the find its empirical and molecular formula. Now we are fighting for the molecular formula. We need to calculate the we need to find the molecular formula. So the formula for the molecular formula is equal to n into empirical formula. Okay, n into empirical formula. So sir, what is this n? What is this n? So this n is nothing but, you can see from here only, that is n is nothing but the molecular weight divided by the empirical formula weight. Okay, this will go over here, and where then you get the n, the value of n. Okay, so sir, n is equals to molecular formula weight divided by empirical formula weight. Correct? Yes. Molecular weight divided by the empirical weight. So molecular weight we have 166. Okay, 166. The empirical formula weight we also are having 83. Yes sir, 83. So when you divide 166 by 83, you get the answer is equals to 2. Okay, now we put this 2 value of n over here, and you will get the answer is equals to molecular formula is equals to 2 into empirical formula. But sir, what is empirical formula? Empirical formula was C4O2H3. So 2 into C4O2H3. So it would become C8O4H3, or you can write down C8H, I think 6, sorry, H6 and O4. Okay, so it's 4 to the 8, 2 to the 4, and 3 to the 6. Okay, so this is nothing but the molecular formula. Okay, let's see again how we solve this type of question. Okay, so we started with the making this table over here, where the table contains the part, element, percentage composition, atomic weight, relative number of atoms, and simple ratio. Okay, then we put the all the elements present, which is carbon, oxygen, and hydrogen over here, and then we add the percentage composition. And once you add the percentage composition, you have to write down the atomic weights of the elements given. Okay, then you have to divide the percentage composition by atomic weight, and you will get the relative ratio. Okay, then you have to select the one ratio which is the smallest smallest among all. Okay, the smallest among all ratio you have to select and you have to divide all the other relative ratios by that smallest ratio, okay, in order to get the simple ratio. And once you get the simple ratio, you have to put all the elements in the form of ratio, that is C is to O is to H and 2 is to 1 is to 3 by 2. If any pair you can see the fraction, you have to remove this fraction by multiplying it with the same number. So we in order to remove the 2, we multiplied every ratio by 2, okay, and we got the final ratio 4 is to 2 by 4 is to 2 is to 3, okay, and that's nothing but our empirical formula. Then next step was to calculate the empirical formula weight, which we calculated over here, and second step was to calculate the molecular formula weight or molecular weight, okay. So in order to calculate the molecular weight, we had the formula 2 into vapor density. Vapor density was given, so we calculate the molecular weight also, okay. Now as we know the molecular formula, the formula for the molecular formula is n into empirical formula. So we have to calculate this n. We know the empirical formula, we have calculated above, okay. So n is nothing but the molecular weight divided by empirical formula weight, okay. We know the molecular weight, we know the empirical formula weight as well. When you divide and you get the 2. So nothing but, in order to calculate the molecular formula, is nothing but the n into empirical formula, and we calculated, which was 2. So 2 into C4O2H3 would be C8O4H6. So this is how we solve this type of question. If you have any doubt, you are studying this for the first time, revise the concept once again by watching a video, or if you still have a doubt, you can comment your doubt in the comment section and we will make a dedicated video towards your doubt on our channel. Till then, keep on studying and keep on asking doubts in the comment section.